Hi and welcome to challenge number 11, sum of elements. The statement for the challenge reads that we need to sum all numbers in an array. So the input is going to be an array. It is going to look like this. So we have 4 numbers. We could have more or less, but it should be a list. It should be an array. And the output is going to be one number. And that number is going to be the sum of all of the numbers found inside of that array. Now, the way that I'm going to go about this is we are going to first jump, much like the previous 10 challenges, into JavaScript, but we need to also take a look at if the array contains nothing, if it contains only strings, or if it contains a mixture of both of them. Now, if you were sure that you were going to get just an array of numbers, the solution for this challenge would be just one line of code. But if we want to take into account all of these edge cases, then the solution is going to get a little bit more complicated. And as we move along these languages, you're going to see how every language is going to implement that differently. So when it comes to JavaScript, the first thing that I want to do is I want to create a function that is going to be responsible for the summation of all of the elements. This is going to accept an array. And what this is going to produce is going to be just one number. Now, since we're in JavaScript, we can't type annotated, but that's the requirement for the challenge. Now, the first edge case that I want to handle is what if the array is empty? So I'm going to say if array.length is 0, then I just want to return 0. So if there is nothing within the array, there is nothing for me to sum up, so it's going to be 0. Now that we have handled that, let's first off extract all of the numbers from the array, because we can only combine numbers together. So I'm going to grab my array, and on the array, I'm going to call the filter method. The filter method is going to implement one logic for all array elements. So it's going to be some sort of a loop that's going to jump into our array and it's going to implement something that we wanted for all of the array elements. Now, what we want this to implement is a simple condition. So we are going to say for every individual item, take a look at the type of that item and give me only the items whose type is a number. Now, this is going to produce a new array because that's what the filter method does. It's going to create a new array for us. And we're going to call that array numbers since it just contains numbers. And we're going to put it inside of this variable. So this variable numbers, it just contains numbers. Now, if user has passed an array of strings, and it is going to pass the first check because the length of the array is not 0. That we know. But once we get to line number 6, since there is not going to be any number, this numbers array is going to be empty because there is nothing, there is just strings, and we only filter out the items whose type is a number. Now, if the array is all strings, this numbers is going to be an empty array. And we need to check for that because if the array is empty, if the array contains strings, we need to give the user some sort of a message to tell them that you didn't pass in any numbers, you just passed in strings. You need to pass in numbers for me to sum them up. So I'm going to say if numbers.length is equal to 0, I know it could contain strings, but remember, we just filtered out the numbers. We left behind the strings. So if you leave behind the strings, the numbers array is going to be 0. It's going to have a length of 0. Now, how do we actually check this? If it contains any of the strings that we were talking about, we could do another check here as well. So I'm going to say array.sum and item. Now, you don't really need to do this because at this point, you will just have strings, but I just want to do this just to make sure. So I'm going to say if the type of item is equal to string, then I'm going to store this within another string, another variable, and I'm going to call it has strings, and I'm going to initialize that as well. Now, if has strings is true, that means I am sure, right now I'm 100% sure that the array contains only strings. I am going to return one simple message. I'm going to say array contains only strings. Please add numbers to sum. There we go. That's going to be our message. Now, at this point, since we just have strings, we have nothing else, we still want to return a numeric value to the user, and that's going to be 0. Now, outside of this, we just have numbers. So outside of the if statement, at the end of this function, we either have an array of one item, but that item is going to be a number, or array of several items, and that's going to be a number as well. So at this point, we have done a couple of checks. We know that we are just ending up with numbers. So how do we sum up numbers? We can use the reduce method. This is a very interesting method. By default, it's going to accept 2 parameters. One of them is going to be the current count. Now keep in mind, whenever we have these sort of methods that work on arrays, the way basically the fundamental way that they work is by looping or iterating over array items, because an array could have one item or several different items. And then by iterating over an array, what we mean is we select one item, implement some sort of a logic on it, and then we select the next one, and then we implement the same logic, and then we select the next one, and then we implement the same logic. So at the end of the day, the logic is going to be the same. It's just the array elements that's going to be different. If an array has 4 elements, in the first iteration, you're going to select the first item or the first element. And in the second iteration, you're going to select the second one, and then the third one, and then the fourth one. So you're going to basically move along the array, and you're going to move for as long as the array has, for as many as the array has items. And that's how these methods actually work. So filter is going to loop over the array. It's going to select one item. It's going to implement some logic, but the logic is going to be filtered out. Reduce is going to implement a different logic, and then sum is going to have a different logic. Map is going to have a different one. So all of these methods, their names are very, very intelligent. So reduce is going to select our array. So reduce basically means you give it something big and it gives you something smaller in length or in quantity. So we give it an array that has 4 items. It's an array, it's a complex data type, and it just gives you one number. It simplifies that. It breaks it down and it gives you just one thing. That's why it's called reduce. So at the end of the day, the input is always going to be larger than the output. All right. So we're now this reduce by default, it has 2 parameters. It's going to have the sum, which is going to be, it's actually called aggregate, which holds the current number of basically the current sum of the elements up to that specific iteration count. And then you have the num. You could call these whatever you want, but a reduce method is going to understand that. And then you have num, which is going to be that current iteration within the array. And I'm going to explain how this works. So we're going to grab the sum, we're going to add to it num, but this reduce method, in order to work on an array to count its items and sum them up, it needs to have an initial value. And the initial value is going to be 0. So we're going to have 0. Let's say the array is 1, 2, 3, 4. In the first iteration, num is going to be 1. And then sum is 0. So this 0 is actually the value of sum. So 0 plus 1, we get 1. And we store it within the sum because sum is the aggregate. In the second iteration, num is going to be 2 because array contains 1, 2, 3, 4. I could just write that here, 1, 2, 3, and 4. So in the first iteration, we got 1. Sum is now 1. And then in the second iteration, we get 2. So 1 plus 2, that's going to give us 3. So now sum is 3. In the third iteration, we get 3. And then, so num is going to be 3, sum is going to be 3, and that's going to be 6. And in the final iteration, we get 4. And then, so you can see we do the same thing over and over, so we can cover all of the array items. That's why we do it over and over. So the current value in the final iteration, the current value of sum is going to be 6, and number is what? 4. 6 plus 4, that's going to be 10. That's why here you can see it says 10. The output is 10. And now we need to store this output somewhere. Just close that. So where am I going to store it? I could just return this. Now at this point, I've made a mistake, and that the reason for it is because we no longer have this array, because we actually filtered out all the numbers and we put it inside of this numbers array. So we need to iterate over or reduce the numbers array, and we can just return that from the function. Now in here, I'm going to have several log statements, and this is going to say test cases, and we're going to go like this for the rest of the languages as well. Let me bring this down. So you know what? I've already created all of these and I don't want to waste your time. So I just want to copy paste that here, and we're going to go over this. So if we pass in 1, 2, 3, 4, and we call the sum of elements, so this is going to be just a string comment for us. So what if we pass in 1, 2, 3, 4 to the sum of elements, we expect the result to be 10. And now let me run this. So this is going to be CD011. It's for CD there. And then I'm going to say node. Come on, buddy. Node a tab, hit enter. What is going to be number is not defined. Oh, this should be in quotes. Very good. Let's run this again. And we can see we have our test cases string right here. And then if we pass in numbers only, the result is going to be 10. So let's do a couple more checks. What if I pass in a string and a number? Can I put these on one line? Oh, I can't. So if I pass in 1 and then hello, which is a string, and then 3 and then a world, which is also a string. So based on this logic that we have on line number 6, where we filter out only the numbers. So from this array, we're going to filter out 1 and 3. So the numbers array, that is right here, this is going to contain 1 and 3. And if we sum 1 plus 3, that's going to be 4. Let's run this again, and there we go. We get 4. For the next test case, I am going to have two numbers which have decimal points, and then we have an empty string and an empty string with several spaces. Let's run this. So we select only the numbers 11.5, 83.1, which is going to be 94.6, and we ignore the strings that are there. Now, what happens if I pass in only strings? Now remember, if I pass in strings, then we basically jump inside of this if statement, because this if statement says if numbers is an we only select the numbers from the array that has been input into this sum elements. And if there is just strings, that means the number's length is going to be 0. And we do another check just to make sure, and then we return this message. There we go. Now, if this check fails and we have any other thing in there, we just return 0. Let's run this, and there we go. So if the input array is hello and world, we're going to send a message to the user that's going to say, array contains only strings. Please add numbers to sum. Let's pass in an empty array. Let's see how the function is going to behave. So if it is an empty array, we know that it's going to be the first test case and the result is going to be 0. There we go. So it's 0. What if I pass in just one number? Then we don't, since we just have one number, 5 plus 0, it's going to be 5. We're going to get to this reduce method, and it's going to produce 5 for us. Save that, run this, and there we go. We got 5. And I'm going to do one more. What if we pass in a single string? Let's run this. We should still get the same message. Array contains only strings. Please add numbers to sum. So this is the result that we're looking for right here. So let me highlight it like this. This is our result, and the entire aim of this challenge is to get the same thing from the other 4 languages as well. It should be the same thing. We're going to have the same test cases, and in any of these test cases, we need to produce the same thing. All right, so we're done with the JavaScript solution. The next one is going to be TypeScript. Let me collapse that. And for TypeScript, I'm going to try to implement this a little bit differently. Here we're going to have the same function that is going to sum the elements. This function is going to accept an argument that's called R or array, but the type of this is going to be limited. This is going to be either an array that has numbers inside of it or strings, or it could also be a combination of both of them. But what this function is going to return is going to be either the sum of these numbers or a message that is going to tell the user to pass in some numbers to sum. Now, the first thing that we're going to do is we're going to take a look at the length. So now that we know this is an array, we have all of this autocomplete. If I take a look at the length, and if the length of the array is 0, that means the array is empty. I am going to return 0 here. Now, we are going to go as manual with TypeScript as possible. So I am not going to use the filter method. I'm not going to use the sum method, and I'm not going to use the reduce method. But we need to implement these, manually. Now, we are going to create one variable, and I'm going to call it sum. The type of this is going to be number, just for clarity. This sum is going to act like the sum that we had inside of our reduce method in JavaScript. And then I need to have some sort of a number to take a look at when I'm iterating over my array, as well as if I have any numbers inside of the array. So I use this number for filtering purposes, and I'm going to call it number count. Number count. And the type of this is also going to be number. We are going to initialize it to 0. Now, the next variable that I'm going to create is going to be a flag that is going to be turned on if we find a string, if we hit a string, and it's going to be turned off if we hit a number. So I'm going to say has strings. This is going to be of type Boolean, but initially we are going to assume that we just have numbers in there. I'm going to bring this down. Let's just take a look at this. Now, I need to have some way to iterate over the array items, because when I'm saying iterate, I am taking a look at one individual item inside of the array. And I need to take a look at if that's a number or that's a string. If it is a number, then I'm going to keep it. If that's a string, I'm going to ignore it. And then I'm going to combine all the numbers that I've kept. But I have to iterate so I can go inside of the array and take a look at the items. And for that, we're going to use our good old for loop. I'm going to initialize I, which is going to be our loop agent, or the thing that's going to jump inside of the array. And it's going to select one array item each time. The initial index, since indices start from 0, the initial iteration count is going to be 0. You could say this is 1, but I'm going to go with 0. And then it's going to iterate for as long as the less than one number less than the length of the array. Because indices start from 0, but length, they start from 1. So length is always going to be 1 more than the index. But so if length and index are the same thing, index is going to be one outside of the array itself. So it's going to go out of the bounds of the array, because indices, they start from 0. So if the length is 4 and the index is also 4, length says there are 4 elements, but index says there is 5, because we also count 0. So it's 0, 1, 2, 3, 4. That's 5 elements. But length says 4. So index is going to go out of bound because there is just one more element that we don't have inside of the array. Right? That's why it's always going to be one less than that. But if you say, okay, this is 1, then you can say for as long as I is equal to the length of the array. But I want to go with 0. That's usually the convention. And then we need to increment the count, because once we select the first item, we should increment the count so we can select the second item. And then we increment it again to select the third item, so on and so forth, until we have moved across that array the entire distance. So now I have this item and I want to basically store any of the items that I select from the array inside of an item. So I'm going to create an item variable and I'm going to pass in that current index. So what this is going to give me is, we have this array of numbers, right? It could be numbers, it could be string, it could be a combination of both of them. So at this point, we don't know how many items there are or what is the type of those items. In the first iteration, when I is 0, we select the 0 indexed item of that array. If the array is, let me select one of these examples. So let's select this one. Select this, come right here, put it there. So let's say we pass in 1, 2, 3, 4. In the first iteration, we select 1. So this array in the bracket 0, what this is going to produce is going to be 1. And we put it inside of the item. Okay, I have selected 1 of my array, the first item of the array. So if array is different, this 1 is going to be, of course, different, right? For this array, the first item is 1. So I need to take a look at the type of this 1. So I'm going to say if type of item, we know that it is a number, but since we want to do this dynamically, maybe the next item is not a number. So if type of this is a number, that means we can sum it, right? We can add it to the sum. So we're going to select sum and we're going to set it to the item. And in this scenario, since item is 1, sum is going to be equal to 1. So the value of sum is going to be updated from 0 to 1. Okay. And then what I'm going to say is, I am going to specify that I have found one number. I've found how many numbers? One number. Now, this is going to be 1. This is not the first item. This is the number count. Since we are in the first iteration, we have found just one number. Okay. Now, if I go to the else class, and inside of the else class, what do you think the type of item is? Since we said that this function can only accept a number and a string, so if we have handled a number, what is the other type? The other type is a string. So inside of the else clause, item is always going to be a string. It's not going to be a number. For example, if we take a look at our second test case, mixed with strings, and if I pass that right here, so in the first iteration, we select 1. Let's say this is, I don't know, like 45, whatever, right? So in the first iteration, item is going to be equal to 45. Sum is going to be 45, and number count is still going to be 1 because we have hit one number. So in the second iteration, the value of this I loop agent is going to be 1. So it's going to select the second item, the item that has an index of 1. And which item is that? It's hello. Does hello, so, and then we basically update the item and we pass in hello here. Now, is the type of item number? No, it's a string. So we go to the else clause. Now, Do we care what kind of a string it is? No, we just care that we found a string. So we're going to say has strings inside of the else clause. Has string is set to true. Why? Because we found just one string. So we are going to set this flag to true. Now, remember, we didn't increase the count of this number count because we just found one number. We didn't find a second number. Now, if we go to the third iteration where the value of I is equal to 2, in the third iteration, since iterations start from 0. Okay, so now this item is going to have a value of 3. Okay, so I am within this if statement because this item is going to be of type number. Now, we know that sum is 45. Now, should I update the sum with 3 or should I say 45 plus 3? So we have the previous value of sum and then we add on to it the next value. This is the correct one, right? So for this syntax, what we need to do is we need to select the previous value of sum and it is stored within sum and we need to add to it the current value of the item. Now, why did I get rid of the numbers and put in the variable names? Because variable names are going to be, they're going to hold the updated value. And since in the first array, I do not have a 45, why should I add 45 for the item? I shouldn't do that, right? So this logic, it has to handle all kinds of arrays. So it should be as generic as possible. And by that, I mean, it should be able to handle all test cases, all use cases. So whatever the value of sum is, we're going to add on to it the value of item, and then we store it within sum again. So the first value of sum was 45. Now item is 3. 45 plus 3, that's 48. So the value of sum is 48. But then we did hit a second number. So this should be, so a second number is still going to be 1, right? But then we need to add on to the previous one. So we hit one number and then we hit another number. But where is this one stored? The first one is stored within this number count. So I'm going to put it right there. And whenever we go inside of this if statement, we just add 1 to this number count. Because unless we don't hit a number, we don't go inside of here. And when we hit a number, we want to increment our number count. And I'm going to come back to this. Why is this necessary? Right? So this is going to be our logic. But now, should I hard code this item? No, it's going to be depending on which iteration of the array we are in. So if I'm in the inside of the first iteration, that's why we pass an I, because the value of I is going to be dynamic. Depending on the array, depending on the iteration count, depending on the array item. That's why we just pass it. We just code it as though we can handle all use cases. All right? Very good. So this if statement, the job of this if statement is basically do this. We filter out the array elements that are only numbers. We just filter those out. So this if statement basically replaced this array.filter for us. There we go. This entire for loop, I would say. This for loop, all of this is just not to use the filter method. Why? Because in TypeScript, I tend to show you how these methods work underneath. Now, we still need to have this check. If we have only strings within our array, we need to send a message, right? So how do we do that? We are going to say if our number count, here is the number count. So if our number count is 0, when is that 0? It's when we do not hit even one number. And in which scenario we don't hit even one number? So let me just copy both of these. Put it down below. Take a look at this test case. So we just pass in hello and then we pass in world. So item is going to be hello in the first iteration. Okay. Now, is the type of item a number? No, it's a string. So we go to the else clause and we said that, okay, has string is true. Did we increment the value of number to 1? No, we didn't. It's still 0. because we increment the number count inside of the if statement, not inside of the else clause. So count is still 0. Okay, we go to the next iteration. It says world. We still do the same thing. The type is not number. The type is string. So this flag is going to stay on. It's going to still say true. And did we update the number of the value of this number count? No, we didn't. And it is still 0. Why? Because we didn't go inside of this if statement to update it to 1. So that's 0. So if number count is 0 and strings is set to true, then what do we want to say? It means that the array that has been passed is only of type string. It only contains strings. It doesn't contain any numbers. And then we basically return this message. All right. Now what if the array contains one number or more numbers, and it could contain strings, but it still contains numbers? Now remember, we did the sum. So we have already implemented the reduce here. We don't have to do reduce again. See? This sum plus num, this item acts as our num. Now, why did I say item? Why did I say num? Because by the time I've gotten to this reduce inside of the JavaScript, I know that it is a number because I filtered out the empty array. I gotten only the numbers. I have taken care of the strings within our numbers. So this numbers array only contains numbers. That's why it's called number. But in here, I didn't do any of those. So the item could very well be a number as well as a string. So the item can be both at this point. That's why it says item. It doesn't say number. If it is a number, we do these two things. If it is not a number, we do this. That's it. So sum is going to contain our result. So the only thing we do is we return sum. That's it. That's it. So let's grab all of our test cases and put all of them here. Save that. Let me bring this up, clear this up. TSC B tab, run this. Very good. And then node B tab, run this. Now let's take a look at what we have. So for the numbers, let me go like this. Not that one, this one. So for the numbers 1, 2, 3, 4 array, we have 10. That's very good. For the next one, we have 45 plus 3, that's 48. Very good. For the next one, we have 11, 83, 94.6. Very good. Even though we do have two strings, we have one string there for hello world. We still get our 48, and we have an empty string there and an empty string with several spaces. We still get our number. Now, what if we pass in only strings? You can see we get this message. It says array contains only strings. Please add numbers to sum. Very good. If we pass in an empty string, we get our 0. If we pass in just one number, that's going to be sum plus item, which is going to be 5 plus 0, which is still 5. And we have a single string, we still get our message. So it behaves exactly like the JavaScript one. Now let's jump into the Python solution for this. I'm going to get rid of our terminal. Let me click on Python. So for Python, we are going to go the same way as we did with JavaScript. We're going to have one function that is going to say some elements, and this is going to accept an array. The first thing is if the array length is 0, then we want to return a number. So I'm going to say if length of the array is equal to 0, then do what? Then return a simple 0. Now, outside of the if statement, what we want to do is we want to first take a look at this array if it contains any numbers. And if it contains these numbers, we want to extract it. So if I were to open up the JavaScript solution once more, here, we want to do this array.filter. But how did this array.filter work? it basically selected every individual item of our array, every individual item, and it took a look at the type of it. If the type of that was number, this filter method created a new array and it populated that with all the items that have a type of number. So this numbers is going to be an array that only contains numbers. So we want to do the same thing in Python. And we have this method that is called isInstance. Now, you could pass in here an item, and then you could say if this has a specific type. Now, I want to take a look at any item that has a type of an integer for whole numbers and a type of a float for floating point numbers, or for decimal point numbers, for decimals. So since in Python these two are differentiated, but in JavaScript and TypeScript we just have a number. That's for floating point numbers, that's for whole numbers, for integers, all of that is different. But in Python we have integers and then we have floats. Now, if item has a type of either a whole number with no decimal points, or it is a whole number with decimal points, then the item is basically a number, right? Why do we do this? Because inside of our test cases, we have 83.12. This is a floating point number. But 3 is an integer. It's a whole number. So we need to be able to target both scenarios. Now, if this item has any of these two types, I want to put it inside of an array. Now, in here, in Python, arrays are called lists. Their syntax is the same as JavaScript, but the name is different. And the easiest way for us to create an array is create a list is to use something called a list comprehension. And you could say it's the same thing as this filter method that we have in JavaScript. So on one line, we do two things. We take a look at the type of the item, if that's a number, and at the same time, we create an array and we populate it with the items that are numbers. We can do the same thing in Python. Syntax is different, but the idea is the same thing. So we have this item. What is this item? This item is the same. Let me just put these two side by side. What is this item? This item is the same parameter that we passed into our filter method. So this item and this item is the same thing. And then what did we say? We iterated over our array, right? So let's iterate over our array. We're going to say for item in array. And this is iteration. Let me just zoom this out a little bit. No, this is too zoomed out. Can I put it on the bottom? Come on, buddy. Oh, there we go. Much better, right? So we said item is this item, and then we iterated over. Now, we didn't really see the iteration because filter method abstracts that away. But if it were to show it, it would look like this. We're going to say for item inside of this array. And then what do we want to do? We said if it has a type of string. Remember, inside of this filter, we have some sort of a Boolean expression, right? And Boolean comes from if statement. We're going to say any item inside of the array, if it has a type of an integer or a float, populate this array or this list with that. And then I'm going to store this list inside of a numbers variable. And now these two lines are the same thing. So line 5 in Python is the same thing as line 6 in JavaScript. It's virtually the same thing. Now, let's move forward. Now, what did we do next in JavaScript? We said that if we select all of the numbers and this numbers is empty, what does that mean? It means there are strings inside of there. Okay, so if length, because if it is not empty, that means there are numbers, because we just filtered out the numbers. So why do we say if length is 0? Because if you have, let's say, an array of strings and you filter out and you create a new array by only grabbing the numbers from that array of strings, Do we have any numbers in that array? No, we don't. We just have strings. So this array that is supposed to contain this numbers list that is supposed to contain numbers doesn't contain anything, because in our original array we didn't have any numbers, we just had strings. So we created an array or a list, but it doesn't have anything inside of it. So in this scenario, the array length or the list length is going to be 0. Now, if it is 0, we can do our simple JavaScript check, this one, just to make sure that there are strings inside of the array. So I could create the same variable has strings, and I could say if this numbers list contains any strings, if it contains any strings, then I want to throw a message. But do I want to take a look at this numbers string, or do I want to take a look at my initial array? Because this numbers slice, it doesn't, this numbers list, it doesn't have any strings inside of it. So I'm going to say, we could use the same as instance method, and we're going to say if item has a type of string where inside of our array, but then we need to have our loop syntax, right? So we're going to say for item in array. If there is any of these instances, we can use the any method here. And the any method is going to return true if any of the items meet the condition. All right. What is the condition? The condition says if the item is has a type of string. So we select our original array, we iterate over it using this item. If it has a type of string, this any is going to return true. And when this returns true, what is that? Isn't this exactly like how we did it in TypeScript? It is basically a flag. We turn it on. Okay, and we say, oh, we found a string. So it has string. And if it has strings, what do? We return this message. We say array contains only strings, because remember, why does it contain only strings? Because we have already said that if numbers length is 0, if there are no numbers, it means it only contains strings. You could say the array could be empty, but it cannot be empty because we already handled that. If the array is empty, your program is not going to move from line number 3 to line number 5. It's not going to move. Line number 3 is going to be the end of the function, and no other line is going to be executed if the array is empty. When we get to line number 7, the possibility is only if the array or the list contains only strings, no numbers. And we do the check here, and then we return 0. Very good. Now we need to still sum up our numbers, right? So in JavaScript, we use the reduce method. In Python, it's a little bit simpler. So in Python, what we can do is we can just say return. We have the sum method, and we pass in, do we pass in the array, original array, or do we pass in the array or the list that only contains numbers? We just pass in the numbers one. So this sum is going to basically take a look at, this is basically our reduce. So it has a sum and it has a num, and it's going to basically have an aggregate that's going to hold the updated value of the sum, and then it's going to return it for us as well. Now, we need to have our test cases. So from this point onwards, let me copy that, put it right there. Let me close JavaScript 1. And first off, let's get rid of all of these logs. This is going to be print. This function name is going to be underscore elements. Very good. All of these comments, they are going to be replaced by the pound sign. Save that. Very good. Let's run it. So clear Python C tab, hit enter. And there we go. We have the numbers. We have 10. We have 1 and 3. That's going to be 4. We have 11 and 83. That's 94.6. If the array contains only strings, we show this message. If the array is empty, we return 0. If the array has one item, that's a number, we return that number. And finally, if the array has even one string, we just return this message. So it's exactly like how we implemented it for the previous two languages. Now let's jump into Go and let's try to implement this for Go as well. So the first thing that I'm going to do for Go is I'm going to import our main package. And we are going to have our function. This is going to be some elements. Now, remember, we're in Go, so we need to type annotate everything. So we have this array. This array is going to have either a type of it could accept a string type and it could accept a number type, or it could accept a mix of both of them. So we need to say something like this. So we need to say string or number, right? Number, and then it could be an array, but then what the function is going to return for us will be either a string or it's going to be a number. So it's going to be either a string or a number. Now the thing is that we don't have this in Go. We have something that's called an interface. So I am going to get rid of this, and we have this interface. But the problem with this interface is that, let me just cut it, put it on the other side. The problem with this interface is that it is no longer used. Just add in curly braces. It is no longer used. You could use it still, of course, but it's a better practice if we pass in the any type. So instead of the interface, I'm going to pass in the any type. And we use this any type whenever we have several different types with either one type or several different types within our list. So the array or this list is going to accept several different types because we have two, and it's going to return one of these types. So it's going to return an any as well. All right. So this is the equivalent of that string number inside of TypeScript. Now, we need to first check I could zoom this in. We need to first check for if the list is empty. So I'm going to say if the length of our list or our array is equal to 0, then what do I want to do? I just want to return 0. So that's our very first edge case. Now, the way that I'm going to go about this is we are going to have to handle this much like what we did in TypeScript. And the reason for it is because in Go, we don't have anything that's equivalent to our filter method. We don't have anything that's equivalent to our reduce method. So we need to implement these manually, and we implemented them manually inside of TypeScript, right? So what did we do there? Well, we created a variable that would hold the final value, which we would return from this function, right? This is the final sum of all the numbers within any specific list that we pass in here. Now, this in Go, we still have several different types for numbers. Now, since we are not sure if we want to return either an integer or a floating point number, I'm going to pass in float 64 as a type for this sum. I'm going to initialize this as well. So using var, of course. And this sum is going to have a type of float 64. The reason for it is it could handle, this float 64 can handle both integers as well as decimals without losing precision, right? So that's why we're going to set the type as float 64. Now, we are going to have our variable that's called number count. I'm going to use short variable declaration to initialize it to 0. And then if we hit a number, we're going to increment this to 1. If we don't hit a number, it's going to stay as 0. And finally, we need to have our flag has strings. This is going to be initialized to false, because initially we're going to say we don't have until we jump inside of the list. So we did some sort of a for loop in TypeScript, so we need to do the same thing here. For loops in Python, they generate the same thing that they do in TypeScript. For loops in Go. I'm not saying Python. So they give us the index for which we use this blank identifier because we're not interested in the index. We're interested in the item itself at that index. Let's use our short variable declaration, and this range is going to jump inside of this array or this list for us. Now within this for loop, we need to do a couple of checks. So I'm going to use a switch statement. I'm going to say switch. Let's declare another variable. Let's call it value. I'm going to initialize it to the type of the item. So depending on what the type of the list is that we have passed into the this function, some elements, we're going to do something different. So what are the different types that we're going to pass in? Let's take a look at our JavaScript one. If I come right here, if I take a look at this, in here, the type of the item is integer. So that's one type. In here, the type of item is string. So that's two types. But in here, the type of item is float. So that's three types. And that's it. So I either have a string, I either have an integer or a float. Why didn't we handle floats in TypeScript? Because in TypeScript, again, and JavaScript, number just has one type. But in other languages, like Go, they have several different types. So we need to have three different cases. But these cases, they're going to be based on the type of the item. So we select the item, and on the item, we have this type. Now, the first case, you could go either way. You could say integer or you could say string. The first case is going to be integer. This is how I'm going to go about this. So we're going to grab some, and what we want to do is we want to convert every number that we select from this array or this list that has a type of integer. We want to convert it to a float 64 because that's what we are going to return from the function. Why? Because float 64 can handle integers as well as the decimals. But then we don't want to override the previous value of sum, so I'm going to say plus equal. So this is going to select, it's going to be something like this. So it's going to be sum plus float 64 is a method that is going to convert any number, any integer into float 64. So instead of this verbose syntax, I can say plus. Why? Because we need to keep the previous value of sum and add on to it the next value that we get from this item. Otherwise, we are not going to be able to sum this, right? So if the first item is 1, right, sum is going to be 1. Second item is 2. Do we update sum to 2 or do we update it to 3? We update it to 3 because we already had 1. 1 plus 2, that's 3. That's why we say sum plus the next value. And instead of doing this, this is basically the same thing as this. It's shorter and sweeter. Now, we get our number count and we increment it by 1. It's 0, we increment it by 1. That means we just hit a number, right? Now, what is the next case? Remember, we had a case of integer, a case of float, and a case of string. The next case is if this is a float 64. Now, if this already has a type of float 64, do I dare convert it to float 64? No. I just add it to sum. Add what? Add this value, right? And then, do I dare increment the number of counts, the number count? Yes, I do. Because I still hit a number. Even though one is decimal, one is integer, at the end of the day, both of them are numbers. What is the other case? The other case is if it is a string. So if this is a string, what do? Can I convert it to a number? No, it's a string. So the only thing I do is I turn on this flag. As strings, it is set to true. That means we just hit a string. Very good. Now I'm going to go outside of this. So now sum is going to contain all of the sum of all of the numbers. And we use number count in a different way, just in case we didn't actually hit any number. So in one of our scenarios, we have this hello world. In hello world, this is a list. We don't have any numbers. So in both iterations of this loop, we're going to come to this case. This case is going to be true and true in both scenarios. And in that scenario, sum is going to be equal to 0. And number count is going to be 0 as well. Because if we hit a number, then we increment number count. So if the number count is 0, that means we didn't hit a number. There are no numbers inside of the past string. And we have strings. That means the flag is on. We want to return this message. So it looks exactly like the TypeScript one because it does the same thing, right? But what if we don't go inside of this if statement? What happens in that scenario? In that scenario, that means we either hit one number or more. And do we want to sum them? Yes, we want to sum them. But we have already done that here. There we go. We have added that there on line 15 and on line 15 and on line 18. So the only thing we need to do is just return that sum. And that's it. Save this. Let's select all of our test cases. And copy this, put it down below. So for our test cases, we are going to get rid of... Now, we shouldn't just put it right here. We need to put it inside of our main function, right? Put it right there. And what do we have here? Well, we have all these logs. Let me just backspace that, get rid of all of the logs. We have fmt.println. There we go. Did we import? Yeah, very good. And bad expression. Okay, type is not... Let me move back. Okay, let's select all of these. And then I'm going to do a tab, save this. Now let's see. So what do we have here? Okay, some elements, comma, expecting. Now, the thing is that this function accepts an array or a list that has a type of any. So in front of all of these, so I'm going to select the sum. We need to specify their type. So in front of these, I'm going to do, let's add the correct syntax, any. And what else seems to be the problem? The correct syntax is that these should be within curly braces. So let's add that there. What I could do is just go back a little bit. So I have multi-cursors here. I could add the any, and I could get rid of the first bracket and add and replace it with a curly brace. And now the only thing I need to do is select the second one. There we go. There we go. This is the syntax for any, so we need to make sure that it is correct. So this one should also be square curly braces, and this should also be curly brace. Now, what else is the problem? I think I ate one of the parentheses. Oh, the parentheses down below. Let me put it on one line. Put this on one line as well. This one. And yeah, very good. FMT, we did not import FMT. Let's import that as well. So import FMT. Whoops. Main package main, import FMT. Yeah, that seems to be print. Oh, sorry, this is, it should be capital P. Just a bunch of typos. And now we should be good to go, right? So we're going to say clear, go run the tab, enter, wait a few seconds. Okay, very good. So what do we have? We have 10 for the first array. We have 4 for the second one. We have 94.6 for 83 and 11. Now for the only strings, and we have, we have this 5. Sorry, this 0 because the array is empty. And then we have 5, and then we have the same thing. Now here, what I could do is I could just select numbers only, mixed. Where have I written array? So I could say, yeah, I could say list, right? Save that. Let's run it again. Doesn't really matter, but still. Empty list, single number, and there we go. This is the solution for the Go one. And now let's go ahead and let's open up the file for the Rust solution. So for the Rust one, this is going to be a little bit tricky for us to implement if we want to implement the edge cases as well. So our edge cases are, the first one is easy, that if a list is empty, that's easy for us to implement in Rust. The issue arises here. So this is the TypeScript solution. And in TypeScript, we have specified very easily that the input array is going to have a type of number or a string. And in the Go version of the solution, we specified that it could be of type any. So it could be number, string, or anything else. But implementing this logic in Rust is a little bit tricky. So I'm just going to go ahead and get started with this solution. But the way that we are actually going to solve this is we're going to work with a combination of functions and macros. And I'm going to show you how to create or how to implement types that are flexible. So you could pass in an integer, you could pass in a float, you could pass in a string, and that macro is going to be able to handle that variable types for the inputs. So the first thing that I'm going to do here for now is I'm going to define our SumElements function, and this is going to accept an array. But this list is going to have a very specific type. This is going to be a slice of something that's called an element. Now this element, I'm going to come back to it later, but for now I just want to go ahead and implement this function. And what this function is going to return is going to be a string for us. So if we return like the sum of elements, even though that's a number, we're going to return it as a string, just because, as I said, it's a little bit tricky for us to handle different types for one function. Now, the reason that I'm doing this is because I just want to have one function and one macro that are generic enough to handle all cases. Now, if I were to add several different functions, then I would take a look at the input array or the input list. So if I jump into my JavaScript solution, now you can see here, we just have this SumElements function, and it doesn't matter what the input is. The input could be numbers, it could be a mix of numbers and strings, it could be just strings, it could be empty. We invoke the same function. Now in Rust, this is a little bit difficult. If we handle different types, we need to have different functions. And then that basically takes away from the aim of this challenge. So I need to first analyze the array. If it is a mixed array, then I need to invoke some function. If it is just a numbers array, then I need to invoke some other function. See, we are going to end up with several different functions, but I just want to have one. So for now, we're going to say even if the result is a number, it's going to have a type of string. And if the user just passes all strings, the result is also going to be of type string, but this is going to be an owned string. Now, this function basically selects or accepts a slice of element, and it is going to return a string with either the sum or that appropriate message. And the purpose of this is so we can have like a general summing function. Okay, so let's move forward and let's actually implement this logic. Now, the logic within this function is something that we have done a few times by now. And this is going to be the first one. The first edge case is that if the array is empty, then I'm going to return 0 and I'm going to convert it to toString, because toString is the method that is going to create an owned string for us. So this part is done. Now, I'm going to need to have some sort of variables to track our sum, to track the number count, and to track whether or not we have hit one string or a couple of strings inside of our input array. So I'm going to create a sum variable, and I'm gonna basically initialize it as 0. But since the sum is going to change, I'm going to pass in the mut keyword in there. So it's going to be changing this. Let me just pass in the comma. Next one is going to be our number count. So this is number underscore count. And this is going to track how many numbers we have hit, right? And you already know this logic, how this works. I want to focus more on the Rust part of this solution. And we also have this mut has underscore strings, which is initially going to be set to false. Now, we need to iterate over our input array, and then we need to take a look at the type, right? So let's do that. So I'm going to say for item in array, what do I want to do? Well, I want to match every individual item with a specific type. What is that type? That type is that element type that I've passed into this function as a parameter. We're yet to create this, but once I create it, you're going to really understand it, okay? So here, the first thing that I'm going to do is if any numbers are found within our input array, I am going to grab this number method, and I am going to convert that number into this number method, basically into a number using this number method. And I'm going to pass that number. I could call that value as I did before, or I could just call that n, or I could call it num. If we hit a number inside of our array, we convert it to a number just to make sure that it is a number. And then we are going to sum it. We are going to add it to our sum. So let's just go forward. I'm going to grab my sum. Now I want to add on to the existing value of sum. So I'm going to use plus equal, and I'm going to set it to num. Now, since we have hit a number, we need to grab our number count and we need to increment it by 1. And there we go. Now, what if we don't hit a number? What if we hit a string? Now, if we hit a string, we don't care about what that string is. So I'm going to pass in an underscore. The only thing that I care is I got a string. For example, perhaps the entire array are string elements. So I don't care what's actually inside of that, because I'm not going to destructure it. I'm not going to be able to add it up. So the only thing that I want to do is I just want to know if I've hit a string, and then I'm going to turn this flag on. So I have this has strings, and I can set it to true. And now that this is basically the same thing that we did in TypeScript. We did some sort of this in Go. So the logic is the same. The implementation is more language specific. Now, if any array has all strings, that means the number count is going to be 0, because we didn't go inside of this block, because it had all strings, right? So I could say if number count is equal to 0 and has string is set to true, then I want to return a message, right? And what is that message? I could just copy it from here. This message: array contains only strings. Please add numbers to sum. So I'm going to pass that there, but then I need to convert it to an owned string. So I'm going to say that toString, and there we go. So Now that the if part or the if clause is clear, let's take a look at the else clause. And in which scenario do we jump into the else clause? So we know that if we do not hit even one number, if we do not have even one number inside of our list, and the list contains strings, that's the if clause, and we print that message. Array contains only strings, please add numbers to sum. But what if we have at least one number inside of our list? So we could have one number, two numbers, or three numbers as items inside of the list or inside of the array. Then we jump into the else clause. Why? Because even if we have one number count is going to go up by 1, and number count is going to be 1. And if number count is 1, we do not jump inside of the if statement. We go inside of the else clause. So we have at least one number. What if we have two numbers or three numbers? That's not the point. At least we have one number, and we want to sum that with the current, or basically add it to the current value of sum. But since we are in Rust, we need to take a look at whether or not it has a decimal point. So in our test cases, I should keep this open. In our test cases, the first array that I passed in, it's all like whole numbers or integers. They don't have any floating point numbers. They don't have any decimals. The same goes for the second case, but for the third case, you can see it has decimals. So if it has decimals, we want to show decimals. But if it doesn't have decimals, like 1 and 3, we just show 4. We don't show decimals. So we need to figure out a way in order to understand if sum, which is our final result, contains decimals or not. So there is a method. I'm going to say if sum.fract is equal to 0.0, this basically means if sum has a decimal point. And this fract method, it is going to return the decimal or fractional part of a floating point number. So if it contains that, what do we want to do? Well, we just want to format it as an integer, just to avoid showing that decimal point. So here we could say format, that's going to be a macro for us. It does need that display specifier. And we're going to say sum. Now we want to format it as an I64, which is an integer, 64-bit, right? Now, what if it doesn't, what if it has decimal points? So if it doesn't have a decimal point, we want to format it as an integer or I64. But if it has decimal points, well, we just want to return it. So we're going to say sum, but keep in mind, we have to convert it to an owned string. And there we go. So we're basically done within this function. I did everything that I wanted to do here. Now, there is just still a lot remaining for us. The next thing that I want to do is, first off, basically, I want to define this element so you really know what this element is and what it is that we're actually dealing with. So I'm going to go above this function. This element is basically going to be an enum for us. And the reason that we use an enum in here is because we are going to have, as I said, because we want to handle mixed types of data inside of our lists. If our list contained only just numbers and we were sure that there were just numbers, this solution would have been like so much easier. But since we want to handle numbers and strings, we need to basically make sure that our function is flexible enough for us. And the way that I'm going to go about this is, first we are going to define our number type, and the number type is going to be a floating point number f64. All right, that's our number type. Now I'm going to leave this line number 3 empty, and I'm going to jump into line number 4 because I'm going to come back to this. So our array could accept a number, but that number it could have decimal points or it couldn't have decimal points, right? And then our array could accept strings as well, and the type of that is going to be string. Now, what about this middle line? Now, sometimes our array just contains numbers. Sometimes our array contains strings. but sometimes it contains both of them. So the way that this works is we need to tell compiler that if this string variant is not used during our development, we want to basically suppress some errors inside of our console. All right, and those errors are going to refer to dead code. Dead code is the kind of code that we temporarily do not use inside of our development, but then it's going to throw warnings that you have actually dead code inside of your program. So what we need to do is we need to flag something as dead code in order not to end up with warnings inside of our compiler. All right. Now, the reason that I want to flag this as dead code is because sometimes I just have numbers, but for mixed types, we use strings, right? So if we have numbers, we're going to get errors that you didn't use the string type. Cool. So here this is how we are going to flag this. So this is the syntax for dead code. We're just going to say allow and dead underscore code. And that's it. Very good, right? And I need to add in a comma. So this is going to be our element type or our enum, which is going to be able to handle all of these types for us. Now, there's still a lot for us left to do. And what I'm going to do next is I'm going to start with our macro that we are going to use in order to be able to handle different types of data coming into our program. And you might be having this question, why do we want to create a macro? Well, we want to create a custom macro. The first reason is because we can. The second reason is we want to simplify calling this sum underscore elements function. So we want to be able to call this function and we want to be able to pass in different types of lists. A list that contains only numbers, a list that contains only strings, a list that contains a mixture of both of them. So for that specific reason, we need to be able to basically have this macro so it defines the rules of the trade for us. Now, some things that I'm about to do, they are part of the macro syntax. Other things are the logic specific to our challenge. So macro underscore rules, this is part of the syntax. And then you need to pass in the macro name. This is going to be sum underscore elements. So this is the macro syntax. And this macro is basically going to leverage something that's called a Rust's from trait. And I'm going to come back to that. Those are some things that we need to create and we're yet to create them. But for now, let's just talk about this macro because this is going to be the most complicated part of this entire challenge. So within this macro, what I want to do is, again, I want to be able to call my SumElements function, and that function should be able to accept any kind of data, right? But not any kind, it should be able to accept number and strings, and that's it. So the first case that I'm going to handle is what if our function is called with an empty, basically with an empty array. That's the easier part of it. So I'm going to come down here. I'm going to say if we call our function with an empty array, so I'm going to pass in the empty array right there. As I said, some things are part of the syntax, some things are our challenge specific. Whenever we want to specify a macro, we need to have this double curly braces, right? This is basically we use this to define a block of code inside a macro body, all right? Now, what do we want to call if we pass in an empty array? What do we want to call? We want to call our SumElements function, and we want to basically just pass in an empty array. But it is going to be a slice of an empty array. It's going to be a slice that we pass in to our function. So the first part is, as I said, it's extremely simple. It's the second part that's a little bit more complicated. So first off, the macro syntax, and it should be double and we need to call our sum elements, but I don't know what I'm going to pass in here, right? So let's think about this. The first case was if the array was empty, right? But what about the second case? The second case is when the array contains something. So it contains strings, it contains a mixture of both of them. I don't care. It contains something. So when it contains something, I need to pass in something to this function, right? And that's going to be a slice of array. Why? Because that's what the function accepts. You can see it accepts a slice of element, which an element can specify the types for us. So I know what I've passed in inside of this some elements. It is an array, no matter what the type of that array is. But where is this array coming from? Well, let's go ahead and let's define it. So I'm going to say, now keep in mind, I am yet to provide the expression that is going to calculate the different types. So the way we go about this is in here, I need to define how this function is going to handle the different arrays that it is going to accept. You can see here, I basically passed an empty array and I passed that there as well, because this macro specifies that this function can only handle a slice of an empty list, right? But what about this macro? Now this macro is used to specify that this accepts an array, but then what is going to be the signature for that array? We're going to come back to this. For now, let's just grab this array and let's define this so we know what this is and where this is coming from. And we know that the name of this is going to be array, but the definition of this is going to be very, very interesting. Now we want to create a vector, right? So since we are inside of this macro, we can use the vec macro to create a vector. The syntax for a vector is square brackets, but this vector is going to be repeated for as many items as we have found a match for inside of this macro expression, inside of this parentheses that I'm yet to add. So inside of the parentheses, we add something that's called a pattern, and using that pattern, we find matches. And if we find a match, we send it to something that's called trait. Trait is going to do the conversion for us, and the conversion is going to be either to this type or to this type, which is this enum element. Right, so this is how this is going to flow for us. And then after the conversion is done, we call our sum elements function, which is going to print that to the console for us. So how do we implement this? Well, first we need to make sure that we have the correct syntax. The correct syntax for repeating something several times is this $ parentheses, and then we call our element. On the element, we have this from trait. And what this is going to grab is going to be this element. And this element, it comes from the macro pattern, which I'm yet to create. And then we need to say that we want to repeat this for as many times as there are matches based on that pattern that we are yet to put inside of this macro. All right. So for as many matches there are, we want to repeat this pattern. And once we repeat it, we end up with a vector. So what we end up with is going to be something like this. So this is going to have a type of element, and we're going to have all of the elements inside of it. So we basically collect everything and we convert it to a vector. We put it inside of the inside of this variable, and then we call the sum elements function with it. Now let's go ahead and let's create this syntax for the pattern of our macro. And since this macro is all about creating a vector or a list or an array, we need to pass in the square brackets for it. And let's move forward. The first thing is that I'm going to do is going to be the last thing. So I need to specify that I'm going to need to have commas after every element. So this is how we're going to specify that, and I'm going to explain what this is. So let's go ahead and let's do that. So here you can see this $ and this parentheses, this pair of parentheses. That's basically the syntax that we use in order to flag, basically to tell Rust that we want to repeat anything that comes inside of the parentheses. So we did the same thing here. right here. So we had this dollar sign, and then we had the opening parenthesis and the closing parenthesis there. We basically said that we want to repeat whatever the expression produces within these blue parentheses for as many times as there are matches inside of our pattern. So this thing right here inside of this parentheses, that is going to be repeated several times. So this comma, which is inside of this parentheses, this is going to be repeated several different times. But then for the last item of an array, I don't want this to be the case. So I'm going to flag this as an optional thing that I want to add. So this dollar sign, again, dollar sign, pair of parentheses, this is part of the repetition syntax, and it basically means repeat the pattern inside for every element that we have a match for, right? That's basically what that means. So that's why we used it here as well. And what is this going to match? Well, we might have numbers, we might have like decimal point numbers and whole numbers or integers, we might have strings. So at the end of the day, we might have expressions. But keep in mind, we want to make sure that we can repeat this several different times. So we first need to have our repetition syntax. And inside of there, we have already used this $elem. So let me just copy that, put it there. But this element is going to be an expression, EXPR. Because this might be a number, this might be a string. I don't want to specify what this is. I just want to specify that this is going to be any Rust expression. It could be 1, 2, 3, hello world, whatever. And since we might have several items within our array, we need to specify that here as well. So I'm going to pass in the star. The star is basically going to say that if you have one repetition, or if you have like 0 repetitions or more than that, you need to basically use this pattern to match. So let's go, our macro is sort of completed. So let's go over this one more time, just to make sure that we're all on the same page. So we specified a macro, the name of the macro is some elements. The first case was if we accepted an empty array, or an empty vector, we basically pass that to our sum elements function. So we invoke the function right here. And the second scenario is where we have something inside of our array, but we don't have any clue what that is. And we don't want to know that either, right? So we passed in this array, and we created this array using this macro, this vec macro. And this vec macro is going to use this repetition syntax, and it is going to repeat whatever is inside of this repetition for as many times as the star says. And this star refers to this macro expression up above, this pattern. What is this pattern? If you take a look at this pattern closely, this is any item within our array followed by a comma. That's the pattern. But the difference is we do not specify whether that's a number, so we just say it's an expression. We don't specify if that's a number, if that's a string, whatever that is. And since the last item doesn't need a comma, we pass in this $sign. Now, what is this $sign here? The first $sign outside of the parentheses, that basically specifies that we have this repetition syntax of Rust. But what about this $sign that is right next to this element right here? Well, that's something specific to Rust. Let me just fix this. This is something specific to Rust. And this $elem or element, this is a meta variable in Rust. This $sign basically tells the macro engine that works inside of Rust to substitute element with the match that we have found inside of the input. So any match that we find, we substitute it with this elem. And this is just a flag to tell Rust macro engine to do its job. So it's part of the syntax. That's something that you need to take away from here. So like this exclamation mark, it is just part of the syntax of a macro in Rust. much like this one, much like these double curly braces that we created. This is also part of it, but that's the idea behind it. It basically says insert the matched value for the variable, which is called lm. You could call this whatever you want, but just make sure it has the same name. So lm and then lm there as well. So now that we have created our macro, the next thing is we talked about these trait implementations, and we need to go ahead and we need to create them because we didn't specify inside of our macro what types they are. But then we need to specify them inside of our traits, right? We need to distinguish between these types. And we use these traits to basically be able to convert any type T, any type, to our custom type that we want. So these traits are called trait implementations. And we need to first go over the syntax. So we have this IMPL, this is short for implementation. And then we need to specify what is the type that this implementation is going to accept. So we're going to say from the type that this is going to accept is going to be an integer 32-bit. So this specifies if we have whole numbers inside of our array, like 1, 2, 3, 4. That's going to be I32. And what do we want to do this conversion for? It's going to be for our enum element. And how does this conversion work? So we have this function which is called from. It accepts any number that has a type of I32 and it converts it to a type which is called element. So instead of repeating element, I could just say self, and self is going to refer to our element. And how do we convert it? Well, we do have this method right here. So why don't we just grab that method? But that method is available on the element. So I'm going to say element number, and I'm going to say n, or basically num, is going to be as if 64. Why do we do that? Because that's what we did here. So if you want to have all of your numbers to be F64, you can do that. If you want them to be F32, you can do that. I'm just going to be uniform, and I'm going to have, if I print any number, if I have any number within my input array, the type of that is going to be F64. All right, that's going to be the type. So this is our very first trait implementation. It was very easy, right? This is if we have any whole numbers. Now keep in mind, everything that I've done so far, that's just to allow Rust to accept the input array. We have calculated the output right here, but here, these implementations, this enum, the custom macro, all of these, they're just so Rust can accept different types of items within an array. Now, for the second one, I want to specify if the input contains any decimal, any numbers that are floating point numbers. So we handled 1, 2, 3, 4. Let's handle 11.5 as well. So I'm going to say from, what is going to be the type of that? The type of that is going to be, if it is an F64 already, from our element, well, let's go ahead and let's call our from function. And we say, okay, I have a number that has a type of F64, and I want to convert it to the element itself. How do I do that? Well, I select the element, and on the element, I have this number method, and this number method accepts an F64, and the number is already F64. Do I have to convert it? No, I just have to pass it. And that's it. So we handled both types of numbers, but what about if we have a string? Now for strings, we have two types as well, right? We have string slices in Rust, and then we have owned strings in Rust. But we don't have to have two trait implementations for strings, and I'm going to come to it. Why? So if we have a string slice from our element, what do we want to do? Well, we're going to say fn. We basically want to specify our function. This is going to be a string, This function is going to accept a string which is going to have a type of string slice. We calculated for this element using the self keyword, and let's select the element enum, and it has a string method on it, and we pass in that stir. Now keep in mind, stir is a slice of string. It's a string slice. So we need to convert it to an owned string, and that's it. So we could hit the brakes right here for our trait implementations, or we could just specify even one more. And that one is going to be, that one is going to look like this. So if we already select a number, and that number has a type of if 64, we just pass it to number. We don't do any conversion. So what I don't have to do this, as I said, and you don't have to do this, but just to make sure it matches this number type, it doesn't match it. I would say it's like, so we had 2 for numbers. We could have 2 for strings as well. And in one of these 2, we basically did a conversion. In the second one, since the types matched, we didn't do a conversion. So if we select an owned string, which doesn't really make sense if we pass in an array to Rust, but if we were to select that, how we would go about the conversion of it. So we're going to say this is going to have a type of string for element. It's going to look like our F64 trait implementation, a lot like that. So we're going to say we have a string that is going to have a type of an owned string. This is going to be converted to the element. And how do we convert it? Well, let's select our element. Let's select our string. Now, the string has already has a type of owned string. Therefore, we don't have to convert it. So I can just pass it, and that's it. And that's what I meant by like just making sure that we have one trait with no conversion for number, and now we have one trait with no conversion for strings as well. So let me take a look at this. I believe we are done. We need to run this just to make sure, just so we could find out what the issues are with our code. So what I'm going to do next is just go ahead and create our main function. So I'm going to say if in main, this is going to accept print. We have just done all of the formatting, so you don't have to worry about it anymore. Let's grab our print line. Now, instead of doing all of this, let's just select the JavaScript one. That is easier, right? And put it here. We're going to fix everything and make sure that it matches the Rust syntax. Let me select all of these. First hit tab, and then we have print line macro. Very good. Now this is going to be the same thing, this part, but we don't have the sum elements. Let me select this. Now keep in mind, we called our sum elements within our custom macro, and that makes our sum elements a macro. So we need to call it as a macro as well. That's something that I wanted to point out. And here we need to, here we need to have our display specifiers. So right here, that's our display specifier. I'm going to copy that, put it right there. There we go. So what else do we need? Not sure. So let's just go ahead and let's run it. I'm going to zoom this out. Rust C, Rust C, this is going to be E tab, hit enter. Okay, so it says, let's go to the top, expected identifier. What have I added there? Remove this comma. Okay, just remove the comma. Okay, comma removed. What else? Some implement from, we have, oh, this should be 4. expected one of 7 possible tokens. So they one of these. But what we need to do is we need to just say that here we go. This is 4. And what else? This is, this should also be 4. It's because we say we want to implement this trait for this enum. And the self refers to the enum as well, to that element. Save that. Let's run this line again. Else expected string. Where is our function? So else we it says array contains if it has strings, else remove the semicolon. Okay, remove the semicolon. So let's just remove it. Yeah, just some syntactical part. Believe there's nothing wrong with our logic. There we go. Let's run this, and there we go. So we have our numbers only, which is 10. We have the next one, which is 3. 83 plus 11, 94.6. If both of them contain, if the array or the list contains only strings, we show this message. If this is an empty array, we pass in 0. There's just one number, 5 plus 0. So you can see this 5, it doesn't have any decimal points. And so using this fract, we basically targeted that and we converted its type to integer 64. And there we go. Yeah, and the final one is right here. I want to go over our solution for the challenge just to take a look at this. So we said we want to return a string here. And this is what we did. We returned a string. And by looking at this, what I want to do is I am sort of not satisfied with the result of this. So here you can see, even though this is like 10, but it is a string. It is a string. Let me run this again. Let's clear the terminal. Let me bring this down. Clear terminal. Run this again. Yeah, you can see these are like strings, and it doesn't make sense to return string. And the problem with Rust is I can't just do TypeScript. So if I just open up TypeScript right next to it, I can just do number and string. I can't do this. So if I were like to do this, it wouldn't work. So what I need to do is, if I want to do this, we have already done something like this, where we had this enum, which calculated the type for us. But if I want this function to return that as well, what I could do is I could just create another enum. And I'm just thinking about this off the top of my head. So what should I call it? Addition, sum. I could call it sum result, since this is just going to style the result for us. Now, what types do I want to show here? Let's take a look at our results. Well, let's take a look at this. Let me run this again. There we go. So the result is going to be, now since we are in Rust, there is a difference between integers and floats, right? So we could have integers, that's 1. We could have floats, that's 2. And we could have a string, that's 3. And that's the only 3 possibilities. So either whole numbers or decimal point numbers or strings. So what I could say is I have an integer within here, and the job of this is to convert a number to an I64. Then I could have a float as an output as well, and that's going to be if64. But then I could have a string as well, and I could call that message. And the type of that is going to be an owned string. Now, I want this type to be acceptable by this function. So now this function returns the sum result. So let me just copy that, put it right there. Now I'm not going to run this because this is going to just throw a ton of errors for us, but let's just modify our function so it can handle the sum result. Now here, we don't, the first one is right here. We don't want to convert this 0 to this owned string. So instead of that, what I could say is grab the sum result, and since 0 is a whole number, I could select the integer and I could pass in 0 in there. Very good. This part is done. Let's move forward. Do I want to change this? No, I don't want to change that. What about this? No, these are just, we know what they are. All right, let's move here. So here we have selected our element. We said number, we passed that in there, and we passed if it is a number. So here is the logic. If it is a number, we add it to sum, and then we increment the number count by 1. And if it is a string, we just turn on this flag. We set it to true, and that's okay. Very good. So this logic is okay as well. And the way you can think about this is wherever you want to return something from this function, that's where you need to implement this sum result. So we implemented this here because we return that. We don't do it here because we don't return anything. We don't do it here because this is a for loop. It doesn't return anything. But this if statement returns a few things. The first thing is right here. So this is going to be our message, right? And I am just going to select all of this, wrap it with parentheses, and I'm going to call our message here. Sum result, and let's grab the message. And there we go. So we basically pass this to our message. And since our message accepts an owned string, we could just keep this toString here. And the else clause, we said that if sum is an integer, it doesn't have decimal points, we want to return it as I64. But then instead of this format, instead of all of this, I could just comment this out and come down here. Let's grab our sum result. Now in here, we know that it doesn't have any decimal points. It's an integer. So we need to call our int. And I'm going to pass in sum, and I'm going to convert it to an I64 as well. Just do the conversion. All right. Now we could have specified a trait and did the conversion in there, but that's just too verbose. I'm going to just do it here. Now we handled the string. We handled the integer. What is the other possibility? It's a floating point number, right? So I'm going to get, since we don't want to convert our sum to string, I'm going to get rid of that, or I could just comment it out. And let's grab our sum result, and let's grab the float, and I'm going to pass in this sum in there. Now, why don't I convert it? Because it is already like a floating point number. I guess I shouldn't do that there as well. Let's just say sum. If there are any errors, then we're going to convert it. And for this one, yes, I do want this string not to be string slice. I want it to be an owned string. And yeah, the macro is going to stay the same, but we need to make sure that we can basically show that here. We need to have that pattern matching as well. And the function that I'm going to specify in order to print our result for us is going to be called print_result. This is just going to prettify the result for us so we can understand, okay, what is what, right? This is going to accept a label. The label is this string that we have here. This is going to be the label. And what is the type of that? We're going to say this is of type string slice, and this is going to accept the result as well, which is going to be of type sum result. Now, we need to match based on what the result type is. So here, if we have sum result integer, and the integer is going to accept an n, what do we want to do? We're going to say print line. Let's pass in the macro syntax. So we want to specify the label. Let me just grab the quotes. So this is going to be the label, and this is going to be the basically what the function returns for us. So label and that number that the function returns. Comma, let's move forward with the next one. The next one is going to be float, and that's going to be specified as f, and I'm going to change that to f as well. And the final one is going to be our string. Oh, sorry, it's going to be message. Yeah, we specified it as message. I could say MSG, print line, and here this is going to be MSG. Now for our test cases, I believe we don't have to change anything. Print line label. Let me just take a look at this. We don't have to, except we called print line here, so we don't have to call it here. And I'm going to keep this one print statement test cases, but the other ones, since they need to be connected to our print result function, because now this print result is going to print the result for us, we need to call that function here. So instead of all of these macros, we're going to say print underscore result. Save this. Hopefully there is not a ton of errors. So rust C, just run this. Okay. So what is it saying? Expected 64 found if 64. See? Expected I64 found if 64. Why is this error? I'm pretty sure you can understand. You know what this is. The reason for this is we specified the sum as 0.00. Now, if I change it to 0, let's see how this compiler is going to react. Let's take a look at this. See, here it says, now it's one way or the other. So let me explain this, what the compiler is yelling about. So here, what is the type of this 0? It's I64. It's an integer. It doesn't have floating, it doesn't have decimals. So since it's an integer and we keep adding on to that integer, this part is okay because sum doesn't have any decimals. But what about this part? In this part, since we know sum doesn't have any decimal points, but this float, it wants to have a number that does have decimal points, even if those decimal points are 0 or 0.00 whatever. So we need to either convert this sum to an integer, or we need to convert this sum into a float. Well, how do you decide? Well, you need to know what sum is. If sum is an integer, much like here, take a look at that here. So here it is an integer, right? So if I pass in an integer to an integer function right here, an integer member of the sum result, it's going to work. So this part is okay. So I could say, I could go like this. Yeah, it's like a tick mark. This part is okay. But then this sum is still an integer that we pass in to float. So I need to convert it here. So depending on what the sum is. So if the sum is initially a float, I don't need to convert it to a float. And that was our very first error. I don't need to convert a float to a float because sum in this scenario would be a float. So you can see here it is a floating point number. And here I don't need to do the conversion. I need to do the conversion here. So I could say give me 0. Sum is 0 just to match our other solutions as well. And then which one of these do I need to change? So sum is already an integer, so I don't have to make any changes on line 64. But since sum is already an integer, on line 66, we need a float, so I could say as if 64. That's it. And that's what I said when I meant, okay, let's wait for the compiler's error. And now we get something else. It says I32. This one has an I32. We need to add I32 here. And it says, fract can't call ambiguous numeric, can't call method fract on an unambiguous numeric type integer. Ambiguous. Okay, what is the type of this? You must excuse me, you must specify a type for this binding like I32. So if I say I32, that's going to be an issue. I'm going to say I64, right? Let's run this again. We get another method not found, or let's just set it to 32. And now there could be another issue. Yeah. So you can convert 962 into, yeah. The issue is that fract accepts I32, but then this int accepts I64. Remember here, I64. So we need to convert I32 into I64. And to be able to do that, compiler tells us to use this into. And there we go. Let's see what else. I32 in the current scope. Implementation for A6. Okay, so what I can do is, you know what? I can just say as F64, just convert it to a floating point number, much like what we had before, and just say 0.0. Let's see now. So sum is a floating point number, so I don't have to convert it to a floating point number here, but then I need to convert it to a I64. Sorry, I need to convert it to an integer. Let's see. Very good, it compiled. And let's run it. So we have numbers. We have this one extra. Okay, let me take a look at our this one right here. Let me get rid of this. Get rid of this as well. Let's save this. Let's compile it. Okay. Get rid of the label from there as well. Save that. String hello. So print result. For result some elements. Single string some elements. Expected. It says print result some result. Remove the extra argument. Okay. Let me go back a few steps and get rid of that. Let's save this. Now let's see what is going to be the issue. Formatting specifier missing. Never used. So the label goes in there. It's just the formatting of the output. It's just bugging me a little bit. Now let me take a look at this. I have this extra one here. Print line. Do I need this specifier here as well? Let me get rid of that. Save this. You can see I have double colon. So I have a colon there and then I have a colon there. So let me run this again. Okay, so I got rid of that. Yeah, this, I don't need it here anymore. Okay, that's good. So if I select that, get rid of there, get rid of it there. Since we already have the formatting specifier up above, we just have to pass in 2 arguments to this print result function. One argument is the function invocation of some, basically the macro invocation of some elements. The other one is this label, and here is the label. Very good. So sorry for all of these things because I just thought of it on the spot, and I tried to do it off the top of my head, and that's why there's just a ton of stuff, a ton of errors. Okay, so now what do we have? We have numbers only. We have mixed for, so everything is working as we expected. Now, by looking at these, there is, so if you remember our JavaScript and TypeScript solutions, these numbers, they had a different color. So by looking at these, even though I know that these are numbers, I can't really specify if this is a number. I can, but just by looking at them. From the logic, I know that these are numbers because here is what I've called. So what I could do is I could redefine this function just to make sure that it shows that these are numbers as well. But the problem is that we don't have any compile time type of operator in Rust. So it's everything is way more difficult when we want to implement it in Rust. So I'm going to keep that function up above just in case this doesn't work. So the function name is going to be the same thing, print result. It is going to accept the same thing. You know what? I'm just going to copy paste it down below. Comment it out, comment it back in. So here we have the label, we have the result, and we need to specify our type name. So I'm going to keep these up above. Let's say we have let type underscore name. So what is going to be the type name for us? Now, we know that we have, you know, let me get rid of that. We know we have this sum result. It contains all of the types. Now, we have an integer type, we have a float type, and we have a message type. Now, if I want to show the type, I'm not interested in what the value is because the value is already being shown here. I'm just interested in the type. And we can do the same thing that we did here. So inside of this element iteration, we said that we're just interested if it is a string. We're not interested in what kind of a string that is. That's why we passed in the underscore. So we could do the same thing here as well. I'm not interested in what the actual integer or what the actual float or what the actual message is. I'm just interested if I have found an integer, a float, or a message, right? So if I have found an integer, what do I want to do? Well, I want to show a message. I want to say that this is an integer. If I found a float, I want to show that this is a float. And if I have found a string, I want to say that this is like our message, right? And we need to separate these with commas. Now, I want to be able to do this programmatically so I don't repeat myself several times, but this is going to be part of the result. So I'm going to specify this as a slice. So here I'm going to surround this with a pair of curly braces. Let's put it on the next line. Let's hit tab, hit enter. Very good. And I'm going to say match any of these as a result slice. And whenever you find a match, you just put it inside of this type names or type. From this, we are going to get one individual one. So I could just say type name. Now that we have done that, we need to make some modifications. So we have the sum result integer, and this is going to print the label as well as the number. And we have labels here as well. And I have labels here. How do I connect this to this? Okay, so match results. Okay, print line label. Let's I have repeated label 3 times. So what I could do is I could get label out of there. So I could say print, and this is one display specifier. And then we are going to have another display specifier, but I'm going to put that inside of parentheses. We're going to pass in the label here. So we could say the label could go with our type name, right? And then these ones, they're just going to show us that result. So I could safely get rid of these three labels and could get rid of this as well. Okay, so we shouldn't make any changes to this one. Let's just run it. Let's see what the problem is going to be. Most likely there are going to be problems. Yeah. So let's see what the issue is. So help at, okay, yeah, I didn't terminate this one. That's the match result unexpected token. Online 101. So it's talking about this one. You know, I think that's because of that colon. Let's run this. Oh, we're using the print method, and then we need to call this, right? Add here. Where do I add it? Add here. Oh, here, right there. Let's save this. Let's run it again. Oh, it compiled. I wasn't sure about that. Okay. So let me add a space in there, and then let's just recompile this. And there we go. So what do we get? We get numbers only, 1, 2, 3, 4. This is an integer, 10. 4 is also an integer. 94.6 is a float. This is a message. 0 is an integer. 5 is an integer. And this is a message. Yes, that is it. That's exactly what I want. Oh boy. This was very big. 140. Yeah. So we are done with this challenge. I just, as I said, at the end of the previous challenge, I am more like experimenting with these videos. I want to experiment, I want to learn, I want to understand, I want to fix bugs. So all this kind of stuff, and I don't really worry about the time constraint. So even if it had gone 10 hours, I would have been okay with it, because it's just too much fun for me to just tweak the code and try to implement it, try to make it better. And we did a lot of things here, and I hope you learned a lot of things as well. So with this solution has come to an end. See you in the next one.